Hi, I am Melanie Sklar. I'm a third-year PhD student working with Yejin Choi and Julia Tsvetkov in natural language processing.
My name is Kyle Johnson. I'm a PhD student in computer science and engineering at the Allen School, and my advisor is Vikram Iyer.
I'm Jiafei Duan, a first-year PhD student at the Allen School. I'm part of the Robotics State Estimation Lab and Ranjay Krishnan's lab.
Hi, my name is Chu. I'm a third-year PhD student in the Allen School. I'm part of the Makeability Lab. I'm advised by Professor John Froelich.
This is a great moment to be doing NLP research. Things are changing very rapidly. I focus specifically on reasoning of large language models. One type of reasoning that current large language models don't do very well is theory of mind reasonings. A short story that people usually use to test theory of mind capabilities is called the Sally-Ann test. Say Alice and Bob are in a room where there is a basket and a box. Alice has an apple here. She puts it in the basket and then leaves the room. Now Bob will come and moves the apple from the basket to the box. So the questions that then will ask either a person or a model to probe their understanding of theory of mind reasoning is as follows. Where does Alice think that the apple is? Where does Bob think that Alice will be searching for the apple when she comes back? Where does Bob think the apple is? And those questions do not all have the same answer, but language models will always answer box. The reasoning that's missing is understanding that what you may know might not match what I know. So we'll have several graphs. For example, one graph that says, where will Bob search for the apple? So the beliefs that Bob have. Another graph for the belief that Bob has about Anne's beliefs. So this is what you feed to the language model, and we find that by doing this procedure, you can improve the performance on a theory of mind dataset.
What drew me into robotics was just how interesting it is to be able to make something that can move on its own. And the idea with the microflyer was to take advantage of these small electronics that we've been able to fabricate in the lab in order to control how it dispersed on the way down. So our origami microflyers here were actually inspired by leaves like maple leaves that have similar falling behavior. So in one state, it's flat and it tumbles really far away from the original drop location, but we can control the transition without having a battery, all while it's in the air. And in this state, it's the stable state or transition state, and it actually falls like straight down. And controlling the two states allows us to control how far away these devices float in the wind from the drop location. These things could be used for environmental monitoring, anything from climate change to even monitoring different insects.
I really like the idea of having our own personalized robot butler that's able to perform everyday household tasks for us. So in my research, I look into developing scalable and intuitive approach for collecting large-scale robot data that's able to train such a robot in our own home.
AlgoViz initially was not part of my research plan. I was working on a visualization tool for sidewalk accessibility. And then I realized that this visualization tool was not accessible to screen reader users. I thought I could just adapt someone else's research framework into my visualization tool. It turns out there was no research project at the time, so I decided to come up with my own. So AlgoViz is a system that automatically generates alternative text for screen reader users for geovisualizations. So this is a map of the United States showing the different population density for each state. So over here is a brief summary of the current map visualization. It has a simple spatial pattern summary as well as descriptive stats. I'm going to start interacting with the map. I'll zoom in and now arrow my way around to the East Coast. And then here I can pull up more information.
In the current view, population density is high in the bottom right. Population density is low in the top left. The average population density is 523.3 people per square mile.
At the end of the day, alt text is still unidirectional communication. So I wanted to create something new. AlgoViz 2 is a system that has question and answering capabilities.
Type your question here.
During our user studies, we actually found that blind and low vision people asked many questions that were apparent to visual users. For example, what are the neighboring states of Oregon?
Oregon is bordered by Washington to the north, Idaho to the east, Nevada to the southeast, and California to the south. To the west, it has a coastline along the Pacific Ocean.
So the Allen School for NLP is like the holy grail. It has a lot of people doing great work and very diverse work too. Not only that, but also we get to collaborate quite often with other institutions. So it's a big place to be doing AI.
I'm also the co-founder of Avella, a vision for engineering, literacy, and access. Avella targets underserved youth in the Seattle area, predominantly Black, Hispanic, and Latino youth. The Allen School has actually helped fund the Africatown Community Land Trust. They have the William Gross Community Center, which is like a local makerspace down near the Central District, where we've been going and teaching classes each quarter. Hopefully together we can help impact the next generation of K through 14 students.
The reason I decided to join the robotics lab here at the Allen School is because I've heard many good things that come out from the research here. And not only that, we receive a huge amount of support from the faculty and from our industry partners.
I came to the States doing a master's in urban design and architecture. Then I worked as an urban designer in Chicago for 2 years and decided that's probably not something I want to do for the rest of my life. I wanted to do research at the intersection of HCI and urban science. The more that we can talk to other people, the more that we can benefit from each other's knowledge and skills, the better research that we can create.
My name is Melanie Sklar.
My name is Kyle Johnson.
My name is Jiafei Duan,
My name's Chu, and I am CSE.
and I'm CSE.
I am CSE.
I am CSE.